Force. We hear the usage of this term many times in our day to day life. We might not know that we are using it. Opening a door, riding a bicycle, lifting an object, a few of the most common things that we perform in our daily lives. And all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who is standing on other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk at point A. A person wants to move this desk from point A to point B. Again, how will he do that? Here he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some objects from the table, we say that you applied a force on that object. Here the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here pedaling is the force that we applying on the bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening the drawer, plucking the string of guitar, moving a piece on a chessboard, or some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. We can describe all these actions under two actions, namely pushing and pulling. For example, a book on the table, you can either pull it towards you like this or push it away from you like this. So it can state that a force is a push or pull upon an object resulting from the object's interaction with another object. So this is all about the force. Have you ever noticed that it's harder to start pedaling your bicycle than it is to ride at a constant speed? Or wondered what causes your bicycle to move? Or thought about why it goes forward instead of backwards or sideways? Perhaps not, and you wouldn't be alone. It was not until the 17th century that Isaac Newton described the fundamental laws of motion, and we understood the answer to these three questions. What Newton recognized was that things tend to keep on doing what they are already doing. So when your bicycle is stopped, it stays stopped, and when it is going, stays going. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest. That is Newton's first law of motion. Physicists call it the law of inertia, which is a fancy way of saying that moving objects don't spontaneously speed up, slow down, or change direction. It is this inertia that you must overcome to get your bicycle moving. Now you know that you have to overcome inertia to get your bicycle moving. But what is it that allows you to overcome it? Well, the answer is explained by Newton's second law. In mathematical terms, Newton's second law says That force is the product of mass times acceleration. To cause an object accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. The more force you have to use, the accelerate at the same rate. This is why it would be really difficult to pedal a 10,000 pound bicycle. And it is this force which is applied by your legs pushing down on the pedals. It allows you to overcome Newton's law of inertia. The harder you push down on the pedals, the bigger the force and quicker you accelerate. Now on the final question, when you do get your bike moving, why does it go forward? According to the Newton's third law, for every action there is always an equal and opposite reaction. To understand this, think about what happens when you drop a bouncy ball. As the bouncy ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction, upward, causing it to bounce back up to you. Together the floor and the ball form what's called the action-reaction pair when it comes to your bicycle. It is a little more complicated. As your bicycle wheels spin, the parts of each tire touching the ground push backward against the earth. Actions, the ground pushes forward with the same force against each of your tires. The reactions, since you have two bicycle tires, each one forms an action-reaction pair, and since the earth is really big compared to your bicycle, it is barely moves from the force caused by your bicycle tires pushing backwards, but you are propelled forward. So dear students, this is all about the Newton's laws of motion. I hope today's topic is clear to you. Inshallah, we will meet into next topic. Till then, take care of yourself. Allah Hafiz.